Okay, let's again switch gears and let's talk about the potassium cycle or how potassium cycles in a soil. And in this case, what you see here are you see some lines, but by and large, the cycle of potassium is not as complex as, say, nitrogen, and it's certainly not as complex as phosphorus. So a few things to point out on this slide, and then we'll go into specifics of each one of these phases that you see on this slide. The first thing that I want to tell you is that unlike nitrogen, potassium, and you also learned this about phosphorus, potassium does not volatilize or undergo denitrification, right? So those transformations in terms of losing potassium as a gas to the atmosphere just does not occur. Okay, it's probably somewhat important to realize that potassium is not volatilized or released as a gas from the soil. So the potassium cycle, let's work backwards here. How does potassium get into the soil in the first place? First of all, it starts out as mineral phases. We'll talk about that in a second. Or it comes into being in the soil as plant and animal residues that are added back to the soil that eventually end up as soil organic matter. Okay, so potassium. Plants take up potassium. We know that plants need potassium. We talked about this, and the first thing that comes to my mind is the opening and closing of stomates. So potassium plays a huge role in transpiration of water through the plant. So where do plants get potassium from? Well, they get it from the soil. But in this class, that's too simple of an explanation. The plants, when they take up potassium, they take it up from the soil solution. This is the only area that plants take up potassium. And you learned back in Unit 2 that potassium needs to undergo diffusion to basically pump potassium into the soil solution for plants to take it up, right? And so that diffusion occurs from where? Let's take a look at this. So the diffusion of potassium actually occurs via desorption and adsorption reactions from potassium on exchange sites, on the cation exchange sites. Interesting. So this figure isn't drawn exactly perfect, but how does potassium end up on exchange sites? Well, one way potassium would end up on exchange sites is via the process of diffusion and the reverse, where potassium actually ends up going back from the soil solution and being adsorbed onto exchange sites. So desorption, this is essentially diffusion, and this is readsorption or sorption. There should be a line from soil organic materials and organic matter to this phase, to the exchangeable phase as well. If you added an organic source that contains a lot of potassium in that source, like say manure, some of that potassium is actually going to go from this phase, soil organic, it's not a matter, but organic material phase, to the exchangeable phase. So in soils, disregarding what I just stated, in soils, how does potassium end up on the exchangeable phase? Well, potassium ends up on the exchangeable phase from potassium that's released from the non-exchangeable phase. This is potassium that's locked up in the interlayers of 2-to-1 type clays. And when these 2-to-1 type clays that contain non-exchangeable potassium, when they expand because of wetting, potassium can be released and potassium ends up on the exchange sites on the outside of the clays. So where does potassium come from that's in the interlayer? Well, that potassium comes from the weathering of mineral phases that contain potassium in our soils. So when I think about this cycle, the cycle is rather simple and it's almost, not quite, but almost in one direction, right? So it drives from the left to the right in this bottom portion of the figure. And the potassium that's locked up in mineral phases that contain potassium which are feldspars and micas, this is completely unavailable. This potassium is completely unavailable to the plant. And when these minerals start to decompose due to weathering, so freeze thaw, hot, cold, wet, dry, etc., they weather, and potassium is released from these mineral phases and ends up in the inside of 2-to-1 type clays in the interlayer. This potassium in the interlayer is slowly available. And what does that mean? We're going to talk about this in more detail soon. But the potassium that's close to the edge of the interlayer is more readily released than the potassium that's in the interlayer. And the potassium is released due to shrinking and swelling of these clays. So this potassium is slowly available, but it's not really available to the plant. The potassium on the exchange sites, however, is available as long as desorption and adsorption occur, right? And so the buffering capacity for potassium in a soil is based on the amount of potassium that's on the exchange sites, really. And so over a growing period, when potassium on the exchange sites is being desorbed and adsorbed and eventually being taken up by plants, and these reactions are occurring all the time in a soil, potassium concentrations on the exchange sites decrease over a growing season, especially with respect to alfalfa or fescue, like I shared with you in one of the slides earlier in this unit. And then the buffering capacity is low and we see deficiency symptoms. So what we're going to do is we're going to talk about each one of these phases specifically in the upcoming videos.